Hello to all our friends at home. Today's math lesson is going to be Module 3, Lesson 12, Concept Development. And so we're starting to learn tricks for our nines, our times 9 tables. And I personally love the nines because there's so many different tricks that you can use to learn the nines. So today we're going to be doing an application problem, and we're going to be doing it together to kind of set the ball rolling for our concept development. And then I'm going to show you just one trick for the nines. So today, I'm going to share my screen. And I'm going to show you the basis for our lesson today. Okay. So we all have to agree before we start today that 9 equals 10 minus 1. So look at that number sentence and say to yourself, either you agree with it or you don't. Okay, so another way to say this besides 9 equals 10 minus 1, we can say 9 is the same as 10 minus 1. Well, is 9 the same as 10 minus 1? 10 minus 1 is 9. So yes, 9 is the same as 9. So that's a really important thing for us all to agree on before we start our lesson today. Okay, I'm going to stop my share and I'm going to open a new share with our word problem. And this is what we're going to do together. Okay, boys and girls. So we'll do this one together. All right. Remember, we're going to be using, let's see, where's my annotating? There we go. We're going to be using read, draw, write. So I'm going to put this up here just so we remember R, D, W. So we're going to read the problem and underline our knowns first. A scientist fills 5 test tubes with 9 milliliters of fresh water in each. She fills another 3 test tubes with 9 milliliters of salt water in each. How many milliliters of water does she use in all? Use the break apart and distribute strategy to solve. So often on the application problem, we can really use whatever strategy we want, but on this one, they're telling us specifically to use the break apart and distribute strategy. Okay. So let's go back and underline our knowns. It is important for us to know what a test tube is. So for those of you who don't know, if you're in a science lab, they have these kind of tall, skinny, clear glass vials, and they put things in it, and they mix things together, and they do their experiments with them. And those are called test tubes. It looks like in this problem, the scientist is going to do something with fresh water and salt water, probably seeing how those two kinds of water react with other chemicals. So let's go back and underline our knowns. Actually, I'm going to clear my drawings and I'm going to slide this up just a little bit. Let's see. Okay, there. So we have room to write our target sentence. Okay. So as I read the problem, I want to underline what I know. A scientist fills 5 test tubes with 9 milliliters of fresh water in each. So we have 5 test tubes, 9 milliliters of fresh water in each. What else do I know? She fills another 3 test tubes with 9 milliliters of salt water in each. How many milliliters of water does she use in all? That is our unknown, how much water she uses in all. So as I'm visualizing this problem, I'm visualizing 5 test tubes with fresh water, and then I'm visualizing 3 test tubes with salt water. And so I'm thinking that must be the break apart strategy they're talking about. So let's go ahead and draw, and I'm going to guide you through this. We're going to draw a tape diagram. So let's go ahead and draw a tape diagram. And the first part will be the 5 test tubes with fresh water. So I want 5 units. Okay. And after I get my 5 units, I'm going to put a 9 in each one. And guess what I'm going to put above that? I'm going to put FW above that, because it makes my picture more meaningful, and it reminds me that those are the 5 test tubes with fresh water in them. All right. Now that's not all I need to draw. She fills another 3 test tubes with 9 milliliters of salt water. So now I'm going to add on to my tape diagram, and I'm going to do 3 more units. And again, they're each filled with 9 milliliters of water. Above this part of my tape diagram, I'm going to put salt water, SW for salt water. Okay, and because it's asking me to use the break apart and distribute strategy, I'm going to break those. Let's see what I have. I have 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 nines. I'm going to break it apart into 2 parts, fresh water and salt water. Okay, so let's put a bracket underneath our 5 test tubes for the fresh water. And then we'll draw a separate bracket underneath the 3 test tubes for salt water. Okay. And now I need to start writing my number sentences. So when I look at this first part of my tape diagram, I'm going to say I have 5 equal groups of 9. What math fact can I write for that? Well, I can write 5 times 9. Now, it's pretty hard to skip count by 9, but because my other factor is a 5, I can skip count by 5 9 times. And if you do that, 5, 10, 15, 20, 25, 30, 35, 40, 45, you get 45. Some of you may have had that math fact memorized. All right, that represents the first 5 test tubes. Now, I want you to think about what number sentence you would write for the last 3 test tubes, the test tubes that are filled with salt water. Okay, and if you said 3 times 9, you are correct. There are 3 equal groups of 9. Again, we could skip count by 9 3 times, or if you know your 3s, maybe you have that fact memorized, or maybe you want to skip count by 3 9 times. Either way, you should get 27. All right. Now the question is asking me how many milliliters of water does she use in all? Well, if I know the fresh water is 45 milliliters and the salt water is 27 milliliters, then how am I going to get how much water she used in all? I need another number sentence. And remember, boys and girls, this is your picture. This is your reading and underlining your notes. These are your number sentences, but I'm not quite done. This is kind of a 2-step problem, really a 3-step problem. If I want to figure out how much water she has in all, this becomes a part, whole problem. So what will I do to get the total amount of water? Well, I have to add 45 plus 27. 45 represents the fresh water, 27 represents the salt water. And I do not expect you to be able to do that in your head. So over on this side in my white workspace, I'm going to use the algorithm to add 45 and 27. And if you want to go ahead and do that, I'll give you a minute to do so. Okay, if I add my ones first, I get 12. I have to regroup. 1 plus 4 is 5, plus 2 is 7. My answer is 72. Hopefully you got 72 at home as well. Remember, this is required. It's the number sentence. Do you need this? Well, probably you do in order to actually get your answer, arrive at your answer. This is called an algorithm, okay? So if you do it and you just write the algorithm, you're not going to get full credit because you forgot your number sentence. Most of the time we need both, a number sentence and an algorithm. All right, we read the problem, we underlined our knowns, we drew an awesome picture. We wrote 1, 2, 3 number sentences because it was kind of a 3-step problem. Last but not least, we need that's right, a target sentence. So the target sentence answers the question being asked. How many milliliters of water does she use in all? I'm going to put my TS here to remind myself this is my target sentence. We're going to write she uses, and we got our answer 72. And then I should have done this earlier. The abbreviation for milliliter is lowercase m, uppercase L. So that's the abbreviation for milliliter. She uses 72 milliliters in all. Probably should say 72 milliliters of water in all, kind of dressing up your number, knowing what you're talking about. Okay, and that's our application problem for today. And let's remember, all together, we had 5 9s plus 3 9s, so we had 8 9s. All right, I'm going to clear my picture. And we're going to scroll down, and you guys can scroll down too. You're going to have 4 of these templates, and we're going to show you a different strategy to multiply by 9. Okay. And so I'll do a couple of them with you. I'll probably do 3 of these with you, and I'll let you do the last one on your own after we've practiced together 3 times. All right. So let's think about the problem we just did. We had 8 times 9, didn't we? Whoops. 8 times 9. All right, well, I want a 9's trick. So I can say 8 times 9. If I use the commutative property, what other fact do I learn when I learn 8 times 9? Well, 8 times 9 equals 9 times 8 using the commutative property. Both of those are kind of difficult facts to do. We don't really have a good strategy. That it's not like 5 times 9 and 3 times 9. Those were easier ones. But whether we flip-flop it, we still got 8 times 9, 9 times 8. Many of us don't know our 8s or our 9s yet. So we're going to learn a trick, okay? So we're going to use 9 times 8 is the fact we're trying to solve. So I'm going to clear that and I'm going to write it over here, 9 times 8. That's what we're trying to solve. Because we want to know what 8 times 9 is, but we can solve it using 9 times 8. Buy one, get one, fact free. So count your units here. If we count them, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 units. We want 9 units. We want 9 eighths. The size of each unit is 8. So let's go ahead and put that in there. 8 in each one. Okay, and we counted them. We have 10 eighths. So what I'd like you to do is I'd like you to draw a bracket from the top to the bottom. And if we wrote a math fact for how many eighths we see in our picture, we would write 10 times 8. I'm pretty sure we would all agree on that. 10 times 8. There's 10 equal groups of 8. Well, let's go back to the math fact we're trying to solve them. This is the times 9 strategy we're using. We don't want 10 eighths. We want 9 eighths. So how can I go from 10 eighths to 9 eighths? How about if we do something as simple as crossing off this last unit? If we cross that off, we no longer have 10 eighths. Now we have 9 eighths. So by this one unit, what did I cross off? I crossed off 1 times 8. So go ahead and write that there. Right? I crossed off 1 8. How do we write 1 8? We write it as 1 times 8. All right. Now let's look at this picture and let's remember that I said the strategy we're going to use, and the thing that's really important is that 9 equals 10 minus 1. So let's see how we can use this fact in solving this problem. So we're going to take 9 times 8. We're going to use 2 easier facts to solve 9 times 8. The first easy fact we're going to use is 10 times 8. 10 times 8, we're going to put it in parentheses, represents the entire picture from top to bottom. There are 10 equal groups of 8. But if I only want 9 eighths, what I'm going to do is I'm going to take my 10 eighths, and remember I crossed one off. So what does that really mean? I'm subtracting 1 times 8. Right? I started with 10 eighths. I crossed one off right here, crossed this one off, and then I'm left with these 9 eighths. Here they are, 9 eighths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let's see how this works. Underneath here, I want to put the value of each one of those expressions. So 10 times 8, easy fact, just add 0 is 80. Subtract 1 times 8, another easy fact, 1 times 8 is 8, one and the same. And then if I take 80 minus 8, now you know why we did take from 10 yesterday with our fluency. 80 minus 8 is 72. Our answer for 9 times 8 then is 72. Now, if you can't remember the take from 10 strategy, when you're doing 80 minus 8, remember we decomposed 80 into 10 and 70, and then we said 10 minus 8 leaves us with 2, and then our answer was 72. So that was why we practiced that skill yesterday. So let's just go back and make sure we understand. I'm going to change my color here to red so you can see as we review. What do we want to find? We want to find 9 times 8. What do we have in our picture? All together, we have 10 eighths. This represents the whole picture, all 10 units of 8. What did we do? Well, we came down here and we crossed 1 8 off. So what do? We subtract 1 8. This represents the one we crossed off. This represents the whole picture. So if we take all 10/8, we cross one off or take it away, we would write 10 times 8 minus 1 times 8. We put the value underneath. 10 times 8 equals 80. 1 times 8 equals 8. 80 minus 8 equals 72. And what are we left with if we take 10/8 minus 1/8? We're left with our 9/8. Okay? So that's the way we can use our picture to help us understand how 9 times 8 equals 10 times 8 minus 1 times 8. Okay, I'm going to clear my picture and we're going to do another one now. Okay, you have 4 templates. So I can actually go to a different template. They're all blank. All right, now we're going to do 9 times 6. Okay, our new fact will be 9 times 6. So I'm going to write that right here. We want the answer for 9 times 6. All right. So our unit that we're counting is 6s. We want 9 of them. So let's go ahead and put 6 in each one. Okay. And if you count those units again, and if we write a fact for the whole picture, if you count them, there are 10 6s. So how do we write 10 equal groups of 6? We write 10 times 6. Well, let's compare this to what we want. We don't want 10 6s. We want 9 6s. So what are we going to do? We're going to come down here and we're going to cross one off. What math fact would we write for the 1 6 that we cross off? Well, 1 6 we write as 1 times 6. All right. So we want to find 9 times 6, and let's see how we do it. We take our 9 times 6, and we're going to say, well, that's the same as if I took my whole picture of 10 times 6, and then remember how we got to 9 6s? We crossed one off, so we'll subtract 1 times 6. And so we're saying 9 times 6, or 9 6s, equals 10 times 6, take away 1 times 6. Next, we put our carets and we put the value of each expression underneath. 10 times 6, easy. 6, just add 0 is 60. Another easy fact, 1 times 6 is 6. Then we have to do 60 minus 6. And if you use the take from 10 strategy, that's fine. If you just want to count backwards, you can do that. But 60 minus 6 equals 54. And so 9 times 6 equals 54. And how did we get it? 9 times 6 is a hard fact, but we know 10 times 6. We know 1 times 6. We can calculate 10 times 6, calculate 1 times 6, subtract, and we will get 9 times 6. All right, hopefully it's getting easier for you every time, boys and girls. We're going to go on to the next one. Oops. Okay, and this time, let's see, we did 9 times 8 and 9 times 6. Let's do 9 times 7. We want 9 times 7. So what do we have to fill in every single one of our units? Well, we're counting 7s. So it's 9 equal groups of 7. So let's make groups of 7. Okay, and if you count those, once again, we have 10 7s. So let's go ahead and write our fact for the entire picture. 10 7s would be 10 times 7, 10 equal groups of 7. We need to remind ourselves what we're really looking for. We're really looking for 9 times 7. And at this point, you should know how we go from 10 7s to 9 7s. Go ahead and do it. Very good. We just cross off one of these 7s. And now we're left with 9 7s. Let's write the math fact for that 7 we crossed off. It was 1 equal group of 7. We write it as 1 times 7. Okay, now what we are left with, here, I'll change my color here. What we're left with here then is our 9 7s. We had 10 7s, we subtracted 1 7, and we were left with 9 7s. So let's find 9 times 7 using the 2 simpler facts, because once again, 9 times 7 is a little tricky. But we can say 9 times 7 equals 10 times 7. But that's too much. So the second part of my expression will be 10 times 7 We took 1 7 away. How do we show that in our equation? That's right. We subtract 1 times 7. All right. Now let's put the value of each one of those parentheses. Remember, do what's in parentheses first. We just did that lesson too. 10 times 7, easy fact. 7, just add 0 is 70. 1 times 7, 1 and the same. 70 minus 7 equals 63. So what is 9 times 7? 9 times 7 is 63. We didn't have to figure out what 9 times 7 is. All we needed to know was 10 times 7 and 1 times 7, and we could subtract and find 9 times 7. Pretty cool strategy, don't you think? All right, the last one. I'm going to let you guys do this one independently. And yes, you have to follow the same strategy that we've been doing, because the whole purpose of this lesson is to learn this 9s trick, okay? So the last one you're going to do is you're going to do 9 times 9. We want the answer for 9 times 9. Think about what you're going to put in each one of those units. 9 equal groups of 9. I'll help you do that. We're going to put a 9 in each one of these. I want you to write your math fact for this. I want you to cross the one out, write your math fact for that. And then I want you to complete this number sentence, 9 times 9 equals, with the 2 easier facts. Okay? All right, boys and girls, remember you can flip back and forth. Make sure you're watching the video and listening to me. This really is a kind of a fun strategy. You're using easy facts, multiplying by 10, multiplying by 1, and you're even using the take from 10 strategy we used yesterday. So I want you to go ahead and solve this one independently. Remember to complete the application problem like we did, and complete all 4 of these templates and submit them to your teacher. Okay? Have a great day, boys and girls.